Welcome to this video on the topic of linear relationships. In this video, we'll be having a look at the techniques involved in graphing linear relationships. Now, linear relationship, up until what we've been looking at is we've been looking at equations where there's two unknowns in them. So if we zoom down to this equation here, what we've got is y equals 0.75x plus 3. So we've got an equation and there's two unknowns in it. The reason we call it a relationship is because we're looking at the relationship that y has with x. Now, in addition to being able to represent these in an algebraic form to what you can see here, we're going to have a look at how we can represent these in a visual form. Now, the way in which we go about representing these in a visual form is we like to have them in a specific algebraic form called slope-intercept form. The way in which slope-intercept form is arranged is we go y equals mx plus c, where the m in this particular equation refers to the gradient and the c refers to the y-intercept. Now what we have here is the algebraic representation of this linear relationship y equals 0.75x plus 3. What we want to do is we want to represent this relationship here on the Cartesian plane visually down here. Now the way in which we can do this is we go through a system of 4 steps. Now the first step in the system is we want to identify the y-intercept. The second step in the process is we want to find the x-intercept. And the final step in the process is we simply graph it. Now looking at this, if it was done visually, what we've got here is this relationship could look something like this, where our y-intercept is here and our x-intercept is here. However, this is only but a rough approximation of what it would look like. Rather, we actually have to calculate the values to find them. Now doing this, I'll give myself some space, and I'm going to be quite pedantic about the way in which I'm working this out. Reason for this is I want it to look nice and clear. Alright, so the first step is we want to identify the y-intercept. For this I'm going to say for y equals 0.755x plus 3. Then I'm going to say let x equal 0. Reason being is that the y-intercept is going to go when we cross this y-axis here. And this location here is always when x is equal to 0. So it's always going to be when x equals 0. Because of that, by setting x to 0, we're going to go y equals 0.75x, which is now being replaced with the value of 0 plus 3. Now 0.75 multiplied by 0 is simply 0, so it's 0 plus 3, and therefore y in this case is going to be equal to 3. So we can say y int is going to be at 0 and 3. Now the next step in the process is we need to find the x-intercept. Now the x-intercept, much like the y-intercept was where the line cut the y-axis, the x-intercept is where the line cuts the x-axis, as seen over here. So when this occurs, what we're going to expect is the y-coordinate here is going to be at a value of 0. So what we're going to say is for y equals 0.75x plus 3, we're going to say let y, in our instance, equal 0. Now, as a result, we're going to get 0 is equal to 0.75x plus 3. And now the next step is we have to rearrange this equation to make x the subject. So to do that, we'll take the 3 from both sides, and this will give us minus 3 equals 0.75x. And then I'm going to divide both sides by the coefficient in front of x, which is 0.75. Consequently, what we're going to find is that x is going to equal minus 3 divided by 0.75. Flipping this around, that's going to give us minus 4. Consequently, the x-intercept is going to occur at the location -4 and 0. Now the final step in the process is we simply need to graph the relationship that we've just found. So we're going to go graph using the X and Y intercepts. Now the X-intercept in this case, it is at -4 and 0. So we identify on our X-axis, we go -1, -2, -3, -4. So it's going to cut over here. And we go -4 and 0, like so. And then our Y-intercept, so this green guy over here, it's at 0, 3. So we go 0, 1, 2, 3. So it's going to cut here. From that, what I'm going to do is I'm going to get a pen, and I'm going to use a ruler to neatly draw a straight line, similar to this, reasonably straight. Then I'm going to put 2 arrowheads on it to denote that this is a line as opposed to a line segment. Now the final step in the process of this is, you don't have to do it, but it's always a good idea. You want to label your graphs, or if you have multiple lines on the one graph, what you can do is you can label your lines. In this case, you simply write y equals 0.75x plus 3. And what this does is it lets the person know who's reading your work that this line over here is the graphical representation of this algebraic relationship over here. So this line and this equation are one in the same thing. So this is an example of the steps we go about to graph the visual representation of y equals 0.75x plus 3. So now that A is out of the way, let's have a look at something a little bit trickier. Let's have a look at B over here. So with B, we've got 4y minus 7 equals 5x plus 3. Now what you're going to notice at first is that this particular relationship here, it's not in slope-intercept form. Slope-intercept form is always y equals mx plus c. So, as you may have guessed, the first step we're going to go through to be able to solve this particular problem is we need to rearrange this to be in slope-intercept form. So we go 1, arrange to slope-intercept form. So then we're going to go 4y minus 7 equals 5x plus 3. We're going to move all of our constants to the right-hand side. So I've got a minus 7, so we're going to go plus 7. This will yield 4y equals 5x plus 3 plus 7. And 3 plus 7, that's simply 10. Then we need to get rid of the coefficient in front of the y. So we're going to divide both sides by 4, which is going to yield, use 2 lines for this, y is equal to 5x plus 10, all divided by 4. And I want this to be in slope-intercept form, so I don't like having this fraction over on the right-hand side. So I'll break it down, and I'll go y is equal to 5 over 4x plus 10 divided by 4. And I can go one little bit better than that. If the fractions are rational, I always like to use decimals in place of fractions when I can. So what we're going to find is that if I evaluate these fractions, we're going to get 1.25x plus 2.5. So, alright, now that we've got it back in slope-intercept form, all we need to do is follow the same steps that we carried out in the previous example. So, step 2 in this instance now is going to be find the y-intercept. So we say for y equals 1.25x plus 2.5, let x equal 0, because we're looking for the y-intercept, remember? And then because of that, we're going to get y is equal to 1.25 multiplied by 0 plus 2.5. 1.25 by 0 is simply 0 plus 2.5. And thus, y in our instance is going to be 2.5. So the y-intercept is located at 0, 2.5, like so. Or perhaps, if you're quite astute, you would have identified that the y-intercept here, this 2.5, is simply the c constant in our slope-intercept form. So if you wanted, you could skip all of this intermediate step in here and then just state y-intercept is at 0, 2.5. Don't have to show this working out when you're proficient. Now, next step, we want to calc the X-Intercept. The way in which we're going to do this is we're going to say for y equals 1.25 x plus 2.5, we'll say let y equal 0. Then we're going to get 0 is equal to 1.25 x plus 2.5. We rearrange in terms of x, so we're going to take 2.5 from both sides of the equation here. This will give us minus 2.5 and then 1.25x. Divide both sides by 1.25. This will yield x on the right. Then we'll use a double line. Minus 2.5 divided by 1.25. Flipping everything around. And then computing the value, 2.5 divided by 1.25, that's going to be negative 2. Therefore, X-intercept is going to be located at minus 2, 0 as such. And then the final step in the process is all we need to do now is graph. So graph it using our two intercepts. So our first intercept is y-intercept. It's at 0 and 2.5. So we'll go 1 to 2.5. And then our x-intercept is at negative 2 and 0. So double spacing again, we'll go minus a half, minus 1, minus 1.5, minus 2 as such. Our next step is we draw a straight line with our ruler. If you're doing it digitally, then you can do it this way. Otherwise, make sure you use a straight or ruler to draw a straight line that passes through both points. Center back. Draw in the two arrowheads to denote that this is a line as opposed to a line segment. And then we can write the relationship on top of it. So you've got a choice. You can either write this relationship here, or more preferably, you could go y equals 1.25 x plus 2.5. So the relationship that we deduced over here. This relationship here and this relationship here, they're the same thing. The only difference being is that one's in slope-intercept form and the other's in a non-standard form. So in summary, in this video, what we set out to do was we set out to have a look at how we can go about visualizing the algebraic representation of linear relationships. And the way in which we do that is simply by converting to slope-intercept form, deducing the intercepts, drawing a line, and then labeling the line as seen here.